Welcome. I'm actually excited about the theme of the conference, the notion of the identity engine, where we build things that are hopefully useful, and then we use them. But warning, there may be some assembly required, and I'm going to talk about that with you today. I'm Mike Jones. I'm a consultant in the identity and security space. I both work on standards. I also help people think about how to build out ecosystems. Standards are about making choices. It may seem obvious, but writing things down gets you to think about it, gets me to think about it. So a professional friend, Philip Holland Baker, who, among other things, has been very influential in the PKI space over time, observed to me at an IETF meeting at one point, just in the hall. He said, standards make the choices that don't matter. I thought, well, that's a pretty strange thing to say. But there's actually a deep truth to it. Here's a bunch of choices that don't matter. Hex 800 is the ether type for IPv4 packets. 6 is the IP protocol number for TCP packets. 443 is how you send HTTPS messages over TCP. GET is the identifier for an HTTP method. This longer string says that your HTTP request succeeded. This string types JSON content in HTTP messages. The number 65 is how we represent the letter A, both in ASCII and Unicode. Curly braces are used to delimit JSON objects. Issuer and subject are the names of claims in JOTS. I could go on. In all these cases, different choices could have been made. However, as you're, I'm sure, coming along with me, making choices deeply matters. Because we made the same choices in those cases and thousands of others, we can build systems that interoperate. Standards are where those choices are written down. And it's our job as standards professionals to make good choices. So back to the theme of the conference. The standards are the nuts and bolts of the identity engine. And thinking about the analogy when I was trying to frame my submission, I thought, you know, when we build machines, we have lots of standard parts. We have nuts, bolts, wires, light bulbs, and many other parts, all conforming to applicable standards. And because we have those standards, there's a marketplace of interoperable parts that I can go to Home Depot or Nuts and Bolts in Tacoma and get things that I know will work with each other. Where the alternative is, and most people wouldn't consider this, if we didn't have those standards, every part in every machine would be custom machined. The same is true of the identity and security standards we used to build the identity engine, the digital identity pieces that we build into systems and solutions. But, and I've worked in a number of different standards. Our identity and security standards vary greatly in the degree to which they make choices. Some define one way to do things, and then independent implementers will build something that works correctly together. Others leave a lot of critical choices unmade, passing them on to the implementers. And so depending upon the degree of choices that the standards you're using, your mileage may vary. So I decided to be a little provocative in my submission. I said that I would name names and take prisoners. So I'm going to do that for the next dozen or so slides. I am going to critique, from a personal perspective, a number of the identity and security standards which we use today, and some of which are emerging, some of which I worked on, some of which others did. So here we go. And these are largely chronological, thanks to Steve's suggestion to give some framework for it. X509 is decades old. It's a widely deployed digital certificate format. It predates the web. So this notion of using it for HTTPS certificates, that's an application that came much later. But since that's the application that most people are familiar with, I'm sure some of you have X509 certificates that you've helped create. There are interoperable profiles for that, but they're not perfect. A bunch of the choices have evolved over time. For instance, domain names and TLS certificates used to be in the common name field. They got moved to the subject alternate name field. There's probably people in the room who know why. But all in all, and there's multiple revocation mechanisms. There's CRLs, certificate revocation lists, and there's OCSP, the Online Certificate Status Protocol, and neither of them is ubiquitous. So I will give this one a B. It's not perfectly interoperable, but the industry's done pretty well with it overall. SAML 2, not dead. It's the original single sign-on protocol. It's still widely used. There are interoperable SAML ecosystems, particularly in research and education communities have defined profiles to enable interoperation. It's also the case that in some business contexts, profiles have been defined. When I was still at Microsoft, Microsoft would do a SAML IDP-initiated login flow to ADP for me to get information about my paycheck, and it worked. But, you know, I also helped put ADFS through SAML certification, and it wasn't all that easy. There's different name ID formats. They can be transient, persistent, unspecified, email address, X509 subject name, Windows qualified domain name, Kerberos, and entity, and some others. And unless you choose the same ones, you won't interoperate. There's multiple flows. There's a browser profile. There's an artifact binding profile. You heard Nat say artifact binding a few hours ago. There's the enhanced client proxy profile. There's multiple logout mechanisms. And worse, it's dependent upon really brittle XML canonicalization. So it can be gotten to work. There is some assembly required. But I'll still give it a B. I'll be generous. Okay. OAuth 2, the first one of these that I directly worked on, is not interoperable without a profile. I mean, people asked in an earlier session, well, why aren't there interop tests for OAuth 2? And it's because it's largely impossible. Other than having a few common parameters that you have to give the right names, the choices, things like redirect URI is a choice of an identifier. Aaron could tell you all kinds of stories about how if you use different scope values and you don't understand what they mean, you're SOL. There are multiple token type possibilities, and guess what? OpenID Connect made that worse. The bearer token spec, which is the first one that I was an editor of directly, defines 3 different ways to pass an access token, one of which we even said at the time, don't do this. But because it was in common use, we left it in. I only give OAuth 2 a C. OpenID Connect built an identity layer on top of OAuth 2. It's now more than a decade old. There's an interoperable ecosystem of Connect providers and relying parties because we did make a lot of choices. And in fact, on one hand, we have a certification program that is making sure that people implement those choices faithfully. There's currently, actually, as of last week, probably more now, 754 different OpenID Connect certifications that have happened. And the certification both tries to ensure that something is interoperable and secure. So that's great. But again, we took a strategic decision when OpenID Connect was being architected to build it on OAuth 2 because developers seemed to be gravitating towards that. But that meant, there's layering and we had to introduce stuff. Good news is OAuth 2 was extensible. So we could add things like the ID token and many other things, the nonce. At the same time, there's 6 response types. They have different security properties. There's 3 different IDP-initiated logout mechanisms, 2 of which use the browser, 1 doesn't. This is kind of on par with SAML, actually, for some of the same reasons. But there's still, some assembly required. But like SAML, I'll give Connect a B. We architected Connect to use a bunch of other standards, some of which we put into the IETF. There's a family that we've done in the COSE working group, JSON object signing and encryption. And I'll just talk about JSON web signature today, which is the most used. There's 2 different serializations. There's the compact serialization, where everything is bundled up as base64 URL encoded strings with periods between them. But there's also a JSON serialization that got added pretty late because there were some advocates for that we felt like we were going to have to satisfy to finish it. That adds some stuff that I don't necessarily believe in, like unprotected headers. It did add the ability to have multiple signatures on the same data. So, there were trade-offs. But other than the serialization choice, most of the choices were made by the spec. Now, there's an asterisk on that, which I will talk about in its own slide in a moment, which is the choice of algorithms is intentionally left open to deployments because, what's cryptographically secure for what context is going to change over the time, and we're in a time of such change right now. So the fact that we didn't say you must use RSA SHA-256 for everything gives us this agility to go into the future. So, it largely made good choices. They're working out for people. I'll give it a B. Maybe it should have been a B+ if we're going the plus and minus route. JSON Web Token is built on JSON Web Signature, JSON Web Encryption, JSON Web Keys. It's a representation of a token format using this family of standards. It kind of fills the same role as the SAML token in those ecosystems. And I will say, yes, all the claims are optional at the JOT level. Issuer is optional. Audience is optional. Is that a failure to make a choice? It depends upon your point of view. I don't think so, because each profile defines what claims you must have to work in that ecosystem. So for instance, OpenID Connect defines a profile called ID token, in which not only is issuer required, it says what must be in it and what you can do with it. It says that subject's required, it says that audience is required, it says that issued at is required, it says that expiration is required. There are many different interoperable profiles of JOT in use. One of them is used for securing caller ID in the United States to prevent fraudulent calls. Who knew when we invented this that it would get used for that? Because people have achieved such good interop with JOTs, this is the first one that I'm going to give an A. There's one more A coming. Can you guess? I've also worked on the CBOR object signing and encryption specs, COSE, which is kind of a parallel world to the HOSE specs. It gives you a compact binary format for signing and encryption things. And it makes similar choices to what HOSE did. It does include the protected and unprotected headers, which can get you in trouble if you're not using them well. It has some bells and whistles that HOSE doesn't, such as something called countersignatures, which you can read about in the spec. But it does make enough choices to largely enable interoperability in particular deployments. So, like JWS, I'll give HOSE or COSE a B. CBOR Web Token is a token format we built on top of COSE. It's just like JOT, except everything's binary and smaller, but you can have the same claims. You can have issuer, subject, expiration time, etc. But it doesn't narrow the COSE features used, unlike JOT. JOT said, thou shalt use the compact serialization. So every JOT uses the same serialization, where CBOR Web Tokens allows both single signatures and multiple signatures. There were people who wanted that. I mean, I'm an author on this. But it's the same claims extensibility model as JOTs. But because it didn't narrow some choices that I thought it should have, I'm still going to give it a B. Maybe a B+. Web cryptography is in all the modern browsers. It's the ability to use native speed cryptographic operations on keys that are held within the browser. There's only one way to do each operation. And while there are a choice of key formats, they were chosen to be key formats that were already in production use, widespread, within the web ecosystem. They did not invent another one. So those are the key formats. That's text out of the spec. And, you know, I disagreed with some of the choices made, as will happen. They left out some stuff that some applications needed. In particular, you can only use keys held by the browser. You can't use keys held by the platform. And there were reasons for that, but, you know, as a result, the parts that were specified, everybody does the same. So this is the second A. Well, let's stay in W3C land. Well, but we'll cross over into FIDO land too. WebAuthn and FIDO2 together are tools that we use to build unphishable login. You've heard a lot about that at the conference. It's great work. It evolved from earlier FIDO work called universal second factor, which had a spec called Client to Authenticator Protocol 1. And some of the formats they used for signatures, for instance, were whole X509 certificates rather than just a bare signature. I wouldn't have done that, but they'd done that before I got there. But we decided for, again, ecosystem reasons, to be able to use these U2F keys, many of which are hardware you can't change, and accept that signature format, as well as some others based on the COSE algorithms, again, building on other things. But attestations are kind of a work in progress. Those of you who know that space, there's SafetyNet from Android, there's an Apple attestation, there's TPM attestations, and there's more coming. So it's kind of realistic that they didn't make the choice, but gosh, relying parties' lives would be better if there was a choice or a few. And as a result of the continuing attestation and actually the extensions, there's not general agreement among the browsers and the RPs which of the defined extensions are going to be universally supported. And so, you know, again, your mileage may vary, but good standards. Verifiable credentials, another name that you've heard probably many times this week. Here I'm specifically talking about the W3C version of verifiable credentials. There's other things that are verifiable credentials, such as ISO MDocs and SDJOTs, and that's not what I'm talking about. And, you know, full disclosure, I'm an editor on the V2 versions of this spec. I wasn't involved earlier. They represent cryptographically secured claims about an issuer, or made by an issuer about a subject, kind of like a JOT. But they work in this glorious three-party model. But there's two completely different ways to sign these things. One is the VC Jose COSE specs, which use those underlying specs. And the other is a new invention called data integrity that relies on canonicalizing the JSON before signing it. And within each of those, there's subvariants. There's ways to use JSON Web Signature, or you can use COSE signatures, or you can use SDJOT signatures. And there's actually two canonicalizations in data integrity. There's one where you're canonicalizing to RDF enquads from the semantic web, and the other is using JSON canonicalization. So what do you think I'm going to give this one?
Lower than a B.
Yep, exactly. This is the first C. Decentralized identifiers. I was in the working group that created this. I was also in the deliberations where we tried to have a charter that everybody would agree with. And I took the position that unless we have a few DID methods that are mandatory to implement, we won't get interoperability. I lost that war. As of when I was writing this a week ago, there were 193 registered DID methods, none mandatory to implement. I think there's more now because I'm on the GitHub lists where people register these things. You know, it's all very well intended. Nat talked about XRIs that Drummond invented in 1999, and this is really part of the same family. But because they failed to make a choice about what is needed to interoperate, this gets a D. There's one more. There's a thing called multi-formats, which is used by the data integrity specs, which define a multiplicity of ways of representing the same data, all equivalent. In fact, the multi-base spec, which is the core of this, defines 23 representations for a binary bit stream. And, some are based on base 64. The stars mean that there's multiple of each of these. Some are based on base 68, base 36, base 32, hexadecimal, decimal, base 8, base 2, and binary. If you're going to interoperate with any of the multi-base specs, you have to implement all of them, which is ridiculous. That, or your application has to decide, well, we're only going to use these 3. And some of that has gone on. I kind of forced that to happen in the Verifiable Credentials working group. Because while there was an effort to take this to the IETF and make it a standard, I believe that's dead in the water. Because, the IETF elders, the area directors and the like, understand that standards are about making choices. And this particular spec institutionalizes the failure to make a choice. In fact, I usually reserve my time for advancing things that I think are good ideas. But in the last year, I actually decided this was so bad that I wrote a blog post titled "Multi-Formats Considered Harmful," as this was trying to be promoted within the IETF, and that was at least part of the conversation that stopped it. What do you think I give this? Good call. So I have named names and taken prisoners. Let's have some concluding remarks. Let's talk about choice. Enabling layered protocols is a choice. The fact that Ethernet can carry multiple types of packets, that IP can carry multiple types of packets, et cetera, is not a failing to make a choice. It's enabling layered protocols, and there's a difference. Planning for evolution is a choice. You might take the position, and some have tried in some of the work that I've been involved in, that, well, we should just limit the set of identifiers in this space to a fixed set that can never be expanded. And then it's easier to write interoperable code. But when we were talking about the evolution of Connect, and in fact OAuth as well, the fact that it's been extensible has kept it alive. It's kept it vibrant. The fact that we could add ID token, the fact that Depop could be added, the fact that Pixie could be added, all were critical to the long-term health of those standards. And of course, cryptographic agility. So planning for evolution is a choice. Extensibility is a choice, and this is closely related. One of the inventions that the OAuth working group, I think, borrowed from others, but it's worked out well, was this statement which appears all over the specs. If you don't understand an element, you must ignore it. Well, why is that? It's because then if you extend things for a particular purpose and you return something new, like an ID token or a Depop header, and you don't understand it, you don't break things, you just don't get the new functionality. That's served us very well. So, in my view, standards are about making choices. So please try to make good ones. And I will thank Matter, who's one of my clients, that they donated some time from an actual graphic designer so that these slides have better production values than black text on a white background. Questions? Yeah.
What grade would you give to FAPI?
Off the top of my head, FAPI 1 probably gets a B because it left a lot of things open. And FAPI 2 gets at least an A minus. The only major decision left up to ecosystems is which proof of possession method to use, whether to use Depop or whether to use the TLS. And, there's reasons for that, but again, sometimes you decide to embrace multiple things that are already being widely used as a way to move the ecosystems forward. So yeah, FAPI 1B, FAPI 2A.
Thank you.
Well, thank you for indulging me with your time. I hope you found this maybe entertaining and hopefully useful. Thank you.